So here's the worksheet. Which one would you guys like to see? We have full expansions up here on 1 through 11 odd, and we have finding the indicated term on 13 through 21 odd. We could do a couple of each if you'd like. Which one would you like to see on the first half? Number 3. Okay, let's all go to number 3 here. And we need to expand this binomial g minus h to the 4th power, which means g minus h times g minus h times g minus h times g minus h. Now we could do that, but that will take a long while, and I want you to practice Pascal's triangle and the binomial expansion theorem. So before we even begin, let's get Pascal's triangle going to that 4th degree, that 4th power. So we begin Pascal's triangle with a triangle of 1s, and then we add the 1 plus 1 and get 2, but we put it down here on the next row. And then we put 1s on the outside again, and then we add 1 plus 2, that's 3 right here, 2 plus 1, that's 3 right here. So we're going to put a 3 right there and a 3 right there, 1's on the outside again. And then 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and put 1's on the outside again. So that was a 4 here, a 6 there, a 4 there, 1's on the outside again. And of course, we need to think the power of 0, the power of 0 gives us 1. Anything to the power of 0 is 1. The power of 1 tells us to use this row. Power of 2, use that row. Power of 3, use that row. Power of 4, that's the one we have right here, 1, 4, 6, 4, 1. So how do we use the binomial expansion theorem with Pascal's triangle? You're going to write these numbers followed by 2 sets of parentheses after each number. So we're going to do the number 1 and then do parenthesis, 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 and then plus 4, parenthesis, 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 plus 6, parenthesis, 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 plus 4, and then I'm running out of space here, plus 1. Okay, and then we take the power, the highest power, and if we look at the problem itself, you guys wanted number 3, right? That's a power of 4. That's why we went out to 4 on Pascal's triangle. And we're going to put that highest power of 4 right here on the first parenthesis. And then that 4 is going to decrease to a 3 on the next first parenthesis, then to a 2, then to a 1, then to a 0. So once again, the 4 decreases to a 3, then to a 2, then to a 1, then to a 0. And the second parenthesis, if you started with the 4, which we did, the second parenthesis has to be a power of 0. If you were to add those together, you get that power of 4. But that 0 is going to increase to a 1 as the 4 decreases to a 3. So that becomes a 1 right here, and then it increases to a 2, and then it increases to a 3, and increases to a 4. Ultimately, what happens is that this decreases by 1 as this increases by 1. Ultimately, they end up switching, right? Now, it'd be a different story on the second half of this worksheet. If they said find the second term, you would only be worried about this guy, or find the 4th term, you'd only be worried about this guy. But right here, they do want us to expand the whole thing. So we need to plug in the certain value, the first part of our binomial in the first parenthesis, and the second part of our binomial in the second parenthesis. So going back to the one you just asked me, number 3, the first part is going to be the g, and the second part is going to be the negative h. So the first part's g, the second part is negative h. So first part is g. Put a g on all your first parentheses. And the second part is negative h. So put a negative h right there, negative h right there, negative h right there, negative h right there, and a negative h right there on the last one. Okay, so we're going to zoom in and work on this. Hold on one second, I apologize. Zooming in and working on this a piece at a time. The first part of our answer is going to be pretty simple because negative h to the 0 power, anything to the 0 power is 1. So you could just scratch it out. I mean, you could put times 1 at the end, but that's not going to change anything. Even this times 1 at the beginning is not going to change anything. The only thing we have to worry about is getting g to the fourth power, and that's the first part of our answer, g to the fourth power. Actually, let me do that in red, g to the fourth power. There's the first part of our answer. Then moving on to the second term, we have g to the third power, and we have a negative h to the 1 power. So that's just a regular negative h, which technically is like a negative 1 h, right? So it might make it a little clearer. I apologize. It might make it a little clearer for you if you write the negative h as negative 1 times h. Maybe. I don't know. So if you went negative 1 times h, and then you bring down the g to the third, and then bring down the times 4, then you could think about multiplying the 4 with the negative 1, and that'll give you a negative 4 g to the third with an h. So that's your second term of your answer. And then you move on to the third term of our answer. That's pretty simple. G squared is just g squared with a 6 in the front. And a negative h times itself 2 times will be a positive h squared. So what we really have is a 6g squared h squared. And that is a positive 6g squared h squared. This next one is pretty simple as well. G to the 1 is just a regular g. Obviously, you don't even have to write to the 1 power. So what we have so far is a 4g, or 4 times g if you want to call it. And then the negative h to the third power, that becomes a negative h times a negative h times a negative h. A negative times a negative times a negative is a negative. So you're going to put times a negative h to the third, h to the third. But negative h to the third is really like saying negative 1 times h to the third. So what we really have is 4 times g times negative 1 times h to the third. And we write our numbers together. 4 times negative 1, that'll give us a negative 4. And then the g times h to the third, gh to the third. I apologize, it's getting ugly here. Last but not least, the last term, g to the 0, that's 1. You could scratch that out. 1 times 1 is 1. You could scratch that out. Negative h to the fourth power, that will be a positive h to the fourth. So that's our final term, positive h to the fourth. So here's our answer, positive g to the fourth minus 4g to the third h plus 6gh squared, g squared h squared, and then minus 4gh to the third plus h to the fourth. That's your final answer for that expansion of that binomial. Ugly, huh? But fun. So, is there any other that you would like to see on this worksheet? On the first half? Or jump to the second half? You want to do another one? Which one? 11? Okay, 11. So that would be to the third power. So if we go back to Pascal's triangle that we already did over here, the third power will be 1, 3, 3, 1, right? So keep that in mind, 1, 3, 3, 1, but we're going to put parentheses after each of those numbers. So number 11, we have 1, parentheses, plus 3, parentheses, plus 3, parentheses, plus 1, parentheses. That's how you set it up. And what power belongs right here on the first parenthesis? What power belongs on the first parenthesis? 3.
3.
Okay. And what power belongs on the second parenthesis? 0. Right? So we know that this decreases by 1 as you go to the next first parenthesis, next first parenthesis, next first parenthesis. So you're going to decrease by 1. So the 3 becomes a 2, becomes a 1, becomes a 0. And then the 0 increases by 1 as you go to the next ones, ultimately changing the positions of 3 and 0. So the 0 becomes a 1 right here, becomes a 2 right there, and becomes a 3 right there. And yes, the first parenthesis needs to have the first term of your binomial right in there, which is the c. So you're going to put the c right in there. And the second parenthesis has the second term of your binomial, which is a negative 4d. So you have a c and a negative 4d. a C, and a negative 4D, a C, and a negative 4D. Of course, anything to the 0 power eliminates, so that guy's gone. And your first term will simply be C to the 3rd power. Now, your second term, you have 3 times C squared. If you want, you could write that out. You could write 3C squared or 3 times C squared. And then over here, you have negative 4D to the 1st power. That's really a negative 4D, right? So that's really a negative 4 times D. So what I like to do is multiply the numbers together and then the letters. So let's begin with the numbers. 3 times negative 4, that'll be a negative 12. And the C squared D, you just write them together, C squared D. And that's the second term of your answer. Moving on to the third term. This is pretty simple. 3C to the 1, that's just 3C. So you could write that if you'd like, 3C. And then negative 4D to the 2nd power. What is negative 4D times negative 4D? Positive. 4D squared. Close. What's negative 4 times negative 4? Positive 16. So what we really have is positive 16D squared. So it's kind of like distributing that power of 2. Negative 4 to the power of 2 is positive 16. And then the power of 2 on the D is a D squared. And we are multiplying. So 3C times 16D squared. That's like 3 times 16. That's positive 48. And then the CD squared comes down. Let me stay with the same color. Positive 48. CD squared comes down. And last but not least, C to the 0 cancels out. It becomes 1, right? And 1 times 1 is 1. You don't even need to write it. But we do have negative 4D to the 3rd power. That's like having negative 4 to the 3rd power and D to the 3rd power. Negative 4 to the 3rd power is a negative 64. And D to the 3rd power just comes down. And there is your final expanded form answer of this binomial to the 3rd power. So obviously, the second half of the worksheet is easier because they don't want the whole thing. They just want maybe the 3rd term, or maybe the 4th term, or maybe the 5th term. In conclusion, I'm not going to give you one that has a 10th power, so you guys could skip 17. That's ridiculous going that big. Anyone you'd like to see from here? 15? Okay, that is the 6th power. We want the 3rd term. 6th power, maybe we have it over here already. Maybe not. Let me see. So this is the appropriate row from Pascal's triangle, 1, 6, 15, 20, 15, 6, 1. And we could plug in our first term of 11x into the first parenthesis and the 3y into the second parenthesis. We also, before plugging in, we do the powers. The highest power is 6. Put that 6 on the first parenthesis, and then it drops to a 5, drops to a 4, to a 3, to a 2, to a 1, to a 0. The second parenthesis should have start with 0, and then it increases to a 1, to a 2, 3, 4, 5, 6. And of course, this would be a real long problem to do if we actually had to do the whole thing, but they only want us to do the 3rd term, which is this guy right here. So we could just focus in on positive 15 times something to the 4th power times something to the 2nd power. Okay. So what is that something? The first part of your binomial is 11x. The second part of your binomial, 3y. So we're going to need a calculator because 11 to the 4th power is a huge number. Somebody help me? 11 to the 4th power. So with the calculator, we got 14,641. And of course, we're talking about x to the 4th power, right? Because 11 to the 4th, x to the 4th, there you get the 14,641. Problem is you still need to multiply that number by 15. So if you still have that number on your screen on the calculator, multiply it by 15. And what would we get? In other words, 15 times 14,641. 219,615, like that? Okay. So that's a huge number. And we still have x to the fourth here. Oh yeah, we still need to do over here 3 squared and y squared. So that's going to be a 9y squared. So we still have to multiply it by 9y squared. So multiply this huge number by 9 and tell me what that is. So with the calculator, we get 1,976,535. And of course, we put the x to the fourth and the y to the second right there. And that is technically the answer to this question, the third term of this binomial expansion. So you would type this in on quizzes to get the correct answer. By the way, don't put commas. If you have that huge number, you're not going to have that huge number. But if you ever do have a huge number like 1,000 something, you don't have to put commas in your numbers. Just leave it without commas. Anyways, it's already been a long enough lesson. I'm going to stop right there. You guys feel free to practice with a couple more of these. And I want to try to get a practice test for you guys, or a practice quiz, and then we'll have a quiz Friday.